In this video, I want to talk about the present value of an annuity. We're going to derive a formula that's going to give a great shortcut for you. There's some key things in here for you to pay attention to. The first one is, what is an annuity? So let me give you an example. Let's say that we have a money machine that's going to pay us $1,000 per year for 3 years. That is an annuity because it pays a set amount, the $1,000, for a fixed time, 3 years. So anytime I have the same amount of money coming over a regular time period for a fixed time frame, I know when it ends, that's an annuity. So again, let's say the interest rate is 10%, and how do I find the present value of these three cash flows? So if I have a money machine that's going to make these three payments, how much would I give for that today? Let's do this the way we did with just present value of a lump sum. This is the long way to do it, but it's important that you watch this long way so you get a sense of what's going on here. Draw that line a little shorter. Let's take this $1,000 back to time 0. I do that, I say $1,000 divided by 1.10 to the first power, right? And that's equal to, if I do the math there, 909.09. The second cash flow over here, take it back to today, to time 0. That's $1,000 divided by 1.10 squared, because that comes in 2 periods. And that's equal to 826.45. Alright, the third one, the same thing. That $1,000 comes in 3 years. So what are we doing? Remember, it's the size, timing, and risk of the cash flows. The $1,000 tells me the size. It comes in year 1, year 2, year 3. That tells me the timing. The 10% interest rate has embedded in it the risk. We haven't really covered exactly how that is, but just kind of trust me for now that that's the case. So that's 751.31. So what we have here are 3 cash flows. Cash flow 1 is worth 909. Cash flow 2, 826. Cash flow 3, 751. Add those up, and all 3 of those are worth together $2,486.85. So I'm willing to pay that amount of money for a money machine that creates those cash flows. Alright, but that's a long and tedious way to do it, correct? So let's think about something that may be a little easier. So what I want to look at here is the general term of doing things, and let's say that we have today's time 0, we have time 1, we have time 2, and this is going to go for n years. I don't know how many years, so I'm just going to say n years. And I don't know the payment. The payment is going to be PMT. Let's just call it PMT. Alright, warning, graphic mathematical content coming. Okay, so if you don't like the math, you can fast forward to the conclusion, but I think it's worth your time to see that this formula that I'm going to show you doesn't fall out of the sky. It comes from somewhere. So let's just try to work through this with me. The present value of an annuity, so PVN, present value of an annuity with n years. So present value of an annuity with n years is going to be equal to the payment divided by 1 plus I. I'm going to use I instead of R, doesn't matter. 1 plus I to the first plus the payment times 1 plus I squared plus, keep going, and finally the payment, and I don't know how many there are, is 1 plus I to the n. So it would be routine to have 30 of these, or with a home mortgage there are 360 of them in their months. So I don't want to do 360 terms in one equation. Can I do something a little shorter here? Can I save myself some time? And the answer is yes, and here's how I do it. Let's let D equal 1 over 1 plus I. And the reason I do that is going to make things easier to write. So the present value of an annuity with n years is going to be equal to the payment. I can factor the payment out, times D to the first plus D squared plus dot dot dot. I'm not going to do all of them all the way up to D to the n power. Okay, now here's where it requires a trick. If you were over in the math department, the math guys would say, well, here's the trick, it's pretty easy. And I don't care that you don't recognize this trick. It's not something that I shouldn't use trick, this methodology to solve it. I just want you to know this is how you would do it. Somebody else has already thought of this, so you don't really have to worry about it. I just want to make sure you know where this formula comes from. So I'm multiplying both sides by d. So that would make this, if I multiply this by d, it's d squared plus d cubed, and it keeps going up all the way to this last one is d to the n plus 1. Okay, so what I do next, let me move it over to this side. It's going to get a little sloppy, but you know, the math is what the math is. I can't control that. Present value, and I'm going to subtract d times present value of an annuity, and that's going to be equal to the payment. And here I want you to think about some things. So these d's in here, I'm saying I'm subtracting the second set of d's from those. So there's a d2 in both of them. There would be a d3 in both. There's a dn in both. So this is going to wind up being payment times d to the first minus d to the n plus 1. So now I can rewrite this. I can say present value annuity is equal to the payment times d to the first minus d to the n plus 1, all that over 1 minus d. So I'm just factoring out the 1 minus d. So present value of the annuity is equal to the payment, substituting back in for d. I'm sorry, that's not equal. So be all times, this is 1 over 1 plus I minus 1 over 1 plus I to the n plus 1 divided by 1 minus 1 over 1 plus I. Nice and sloppy, ugly looking equation, right? So this is going to be simplified a little bit. Present value of the annuity is equal to the payment times, make this a little bit bigger, this is 1 over 1 plus I minus 1 over 1 plus I to the n minus 1, and this bottom term is going to be 1 plus I minus 1 over 1 plus I. Math you thought you would never need. Alright, and I'm going to skip up here to the final step, and at the end of the day the present value of the annuity with n years is going to be equal to the following: the payment times 1 minus 1 over 1 plus I to the n, all divided by I. And so now if I think back to what we had before, let's put this in a different color here. I had $1,000 in year 1, $1,000 in year 2, and $1,000 in year 3. Rather than having to do all three of those calculations, I can say the present value of this annuity with 3 years of life is the payment, $1,000, times 1 minus 1 over 1.10 to the third, all divided by 0.1, and that is equal to the same thing it was before, 2,486.85. Okay, so is there an easier way to do that? That's still kind of a sloppy equation. Well, fortunately, yes there is. Your financial calculator has these buttons on it. It has an N, it has a payment, it has a future value, it has an IY, and it has a present value. So if I have 5 buttons, 5 inputs, if I give you a number for 4, you can find the 5th. So in this case, going back to here, the annuity lasts for 3 years. There are 3 total payments. The payments are $1,000 each. This future value term we'll talk about later on, but for now, all that future value is saying, is there anything in the last year? Your calculator is set up to solve one specific problem. It's important to know your calculator is set up to solve one specific problem, and that problem is an annuity that starts in the next year and goes for a certain number of years and might have something at the end here, this future value. You could have an extra payment. In this case, there is no extra payment, so it's 0. IY, you put that in as 10. You solve that, that's 2,486.85. Okay, one last thing, and this is very important. It's very key that you get this this one fact down cold. Present value doesn't mean present value. And let me demonstrate what I mean by that. And this, like I said, is extremely important for you to think about. Let's say that you have an annuity that goes for 3 years, but it starts in year 3. Right? Annuity starts for 3 years, it goes in year 3. So when I do this present value annuity formula, I'm going to do this formula just one more time. This is what your calculator has in it. So here's what your calculator does. If you do the following, you say to the calculator, n is equal to 3, payment is equal to 1,000, future value is equal to 0, and the interest rate is equal to 10%. This tells me the size, timing, and risk of the cash flows. So the calculator says, okay, $1,000 payment, and then I need to do 1 minus 1 over 1 plus the interest rate, which was 10%, raise it to the third power, divide by 10%, and I get 2,486.85. But this equation that we derived assumed something very important. The next payment came in the next time period. So the payment comes in the next time period. That's all your calculator can think about. So the present value doesn't mean the value today. The present value means the value one period before the payments start. So what I want you to do when you do this, when you're trying to solve for this, and you have present value, go ahead and write present value equals the value subscript 2, the value in year 2. So now you know when I do this calculation and I solve for present value, it's not the value today, it's the value one period before the payments start, and the payments started in year 3, so present value is a value in year 2. So if the question asks you what's the value today, that's V0. So if I want to know the value today, V0, the value today is equal to the value in year 2, which is what I found, divided by 1.10 squared. So that is 2,486.85 divided by 1.10 squared, which is equal to 2,055.25. Okay, so now we're at present value annuity problems, and also work ones, it's called, some people will use the term deferred annuity, the annuity that starts in some future time period.